Hello, students. Let me tell you, I'm very excited because we are almost done with our science book. Today, we start a new chapter, Chapter 12 Energy. And how do we use energy? Let's find out. Electricity, lesson number 4. So, let's go to pages 562 to 570 to learn more about electricity. Are you ready? In this lesson, we will be able to describe the characteristics of electrically charged objects and also explain the difference between static and current electricity. Our vocabulary words are electricity, static electricity, current electricity, circuit, series circuit, and parallel circuit. Let's look and wonder. Light bulbs have different parts inside of them. It takes electricity to make them work and give light. But what is electricity? How does it work? In a few minutes, we are going to find out, so please pay attention. But first, let's sing along with an electricity song.
Where do you think it all comes from, this powerful
electricity, electricity?
Through high wires to here it comes, they're bringing the
Electricity, electricity.
every building must be wired to use it.
Electricity, electricity.
Power plants most all use fire to make it.
Electricity, electricity.
Burning fuel and using steam, they generate.
Electricity, electricity.
Turn that generator by any means, you're making a
Electricity, electricity.
A generator is a machine that contains a powerful magnet that creates a magnetic field. When wires are rotated rapidly through this field, then a current of electricity is produced. Now, if we only had a superhero who could stand here and turn the generator real fast, then we wouldn't need to burn so much fuel to make electricity.
Benjamin Franklin flying his kite was searching for.
Electricity, electricity.
He knew that it had something to do with light, and it's all
Electricity, electricity.
rubbing a comb with wool or fur will give you a charge of static electricity. Stroking a cat to make it purr, you're building up static electricity.
Electricity.
Electricity at rest is called static electricity. Like in the winter, wearing a heavy coat, you get a shock off the doorknob, or you scrape across the carpet and sneak up on your very best friend and zap him on the ear with the shock of
Electricity.
Current flowing to and fro makes a circuit of.
Electricity, electricity.
Voltage is the pressure that makes it go. It's pushing up.
Electricity, electricity.
Watts will tell you just how much you'll be using up.
Electricity, electricity.
Powerful stuff, so watch that plug. It's potent.
Electricity, electricity.
Visualize a different world where you couldn't turn on a light, a computer, or even use the electric kettle to make your favorite hot chocolate drink. We use electricity constantly in our daily lives. It is one of our most important types of energy and power that we use. Its uses range from small batteries that operate your remote control car to huge motors that power ships and trains. Electricity operates our lights, runs our refrigerators, kitchen appliances, and powers motors. So electricity is very much important to all of us. It takes a lot of work to generate this magical thing called electricity. Let's first learn the most popular way to generate electricity. How to make electricity. We get the electricity by simply changing other forms of energy. For example, we can burn coal or many other fuels which diverts chemical energy into thermal energy or heat energy. Heat energy will cause water to heat sufficiently and move in a tank. Energy of motion is kinetic energy. The kinetic energy in moving water causes a turbine to turn a generator. A generator changes kinetic energy of a spinning wire or coiled wire to electrical energy. The wire is surrounded on both sides by a very strong magnet. On one side, the negative side of the magnet is facing the wire. On the other side, the positive side of the magnet is facing the wire. Electrons within the wire are attracted to the north part of the magnet and will push away from the south part of the magnet. By spinning the wire, it continuously passes by the two opposite charges of magnetism. The electrons within the wire move towards the positive magnet end and away from the negative magnet end. We see uses of this electricity in our homes and schools. Now let's remember the definition of electricity. Electricity is a type of energy that can build up in one place or flow from one place to another place. There are two types of electricity, static and current. Let's study about these one by one. Static electricity. When electricity gathers in one place, it is called static electricity. For example, when you rub your feet on a carpet and then zap something when you touch it, it is static electricity that you have built up on the surface of your skin, discharging onto another object. Lightning is also a powerful example of static electricity. Current electricity. Electricity that moves from one place to another place is known as current electricity. Examples of current electricity are starting a motorbike, turning on a light, watching TV, playing video games, charging a cell phone, and many more.
Now, let's find out what are series circuits and what are parallel circuits.
Spiky and Bubbles were playing with the ball when it hit the chandelier and the string of decoration lights. Something interesting happened next.
Oops, this is bad. We should have gone outside to play. Hey Bubbles, isn't this strange? Only one bulb of the chandelier has gone out. But for the decoration lights, all the bulbs have stopped working. But why?
Good question. It's time to learn about the types of circuits. An electric circuit is a path along which electric current flows. A simple circuit has a cell, a bulb, and a switch connected by wires. But what happens when there are two bulbs? How can we connect them?
Well, we can connect the second bulb right next to the first bulb.
Or we can connect it above the first one. Well, let's see who's right. Let's make Spiky circuit first. Let's set up the circuit. Now, let's add another bulb right next to the first one. What happens to the brightness of the first bulb?
Whoa, it's dimmer.
Exactly. Now replace one of the light bulbs with a burned out one. What happens?
Both the bulbs go out.
This is a series circuit. If all the electrical components are connected one after another in a single loop, then it is a series circuit. In a series circuit, there is only one path for the current to flow. The amount of current that flows through each bulb of the circuit is the same. Now let's try Bubbles' suggestion. We'll add another bulb above the first one. What happens to the brightness of the first bulb?
It remains the same this way.
Correct. Now replace one of the light bulbs with a burned out one. What happens?
The burnt out bulb does not glow, but the other bulb is still glowing. It is not affected.
Excellent observation. This is a parallel circuit. If all the electrical components are connected in two or more loops, then it is a parallel circuit. In a parallel circuit, there is more than one path for the current to flow. Each loop is independent, so the current in one loop will not affect the current in another loop. So, now we know that both Spiky and Bubbles were right. Spiky connected the bulbs in a series, whereas Bubbles connected the bulbs in parallel. Hence, there are two types of circuits. 1. Series circuits, for example decoration lights. 2. Parallel circuits. Our home appliances are always connected in parallel.
Below is some safety rules before using anything related to electricity. Don't plug a lot of stuff into a single extension cord. Always fly your kite away from power lines. Keeping electrical things far away from water. Do not climb a tree near power lines. Always wear unwet slippers before touching any electrical equipment. Stay away from broken or fallen power lines. Always ask your parents' help before touching electrical equipment.
Visual summary. Number 1. Static electricity is the buildup of charged particles on a surface. Number 2. Current electricity is the flow of electrical charges through a circuit. And number 3. The path along which electric current flows is called electric circuit, and we have two types: series circuit and also parallel circuit. And this is all for today. I really hope you enjoyed this lesson. Remember, if you have any questions, don't hesitate to ask. Goodbye!